சார் ரெடியாக இருக்குது சார், ஸ்டார்ட் பண்ணிடலாங்க சார்.
பண்ணிடலாம் சார். ரெடி.
இப்போ ஸ்டாஃப் ஒருத்தவங்க இன்ட்ரடியூஸ் பண்ணுவாங்க சார். அதுலேருந்து ஆரம்பிச்சோன்னே ஃபஸ்ட்டு வெல்கம் அட்ரஸ் சார். அப்புறம்
சரிங்க சார்.
Very good morning to all. I would like to request Ms. R. Revati, Head of Department, KCE, to give welcome address.
Good morning, everyone. A warm welcome to all for the technical webinar on application of rubberized concrete in construction industry. In this wonderful morning, I welcome our beloved Principal Ma'am, Dr. J. Arbuda Vijay Selvi, who always support us forever. Today we have a proficient person as a resource person. On behalf of Department of Civil Engineering, King's College of Engineering, a happy welcome our chief guest, Dr. G. Venkatesan, Assistant Professor, Senior Grade, Department of Civil Engineering, University College of Engineering, BIT Campus, Anna University, Trichy. Welcome, sir. I extend hearty welcome to all students, faculty members, and industrialists for today's webinar. Once again, I welcome you all.
Thank you, ma'am. I would like to call Mr. R. Sundaram, coordinator of this webinar, Assistant Professor, Department of Civil Engineering from King's College of Engineering, to give introduction for our resource person.
Good morning to all. It's a great pleasure to introduce our resource person, Dr. G. Venkatesan sir, to the webinar on application of rubberized concrete in construction industry. Our resource person, Dr. G. Venkatesan sir, is Assistant Professor, Senior Grade in Civil Engineering Department, University College of Engineering, BIT Campus, and Anna University. He graduated in Civil Engineering from Bharatiyar University in the year 1993 and obtained his master's degree in Water Resource Engineering and Management from National Institute of Technology, Trichy, in the year 2003. He is recipient of PhD fellowship from TEQIP, Government of India, and awarded doctoral degree by National Institute of Technology, Trichy, for his thesis, Comparative Studies on Clay Liner with and without microsilica in permeation of municipal solid waste leachate in the year 2010. He has been involved in teaching, research, and industrial experience for the past 20 years. He has taught more than 20 subjects to UG and PG students. At present, 4 candidates completed and 8 candidates are pursuing their PhD program under his guidance. He has published 41 papers in international and national journals and presented 67 papers in conferences. He published 4 books and book chapters and 2 patent fields. He has carried out funded research project titled Studies on Structural Element by Doting Tire Derived Aggregate, sponsored by Indian Rubber Manufacturers Research Association, Ministry of Commerce and Industry. He have involved consultancy project of improvements and rehabilitation of irrigation structures in Kaveri basins. Preparation of detailed project report, Government of Tamil Nadu. Air quality monitoring, water and soil analysis clients are WAPCOS Limited, Ministry of Water Resources, River Development and Ganga Rejuvenation, Government of Tamil Nadu. Central Public Works, CDM Smith Limited, and he organized 16 conferences and workshops and attended 23 workshops. He has delivered 27 invited talks, conferences, and seminars. He has awarded Vishwakarma Award for the category of Academician for the year 2017, organized by Construction Industry Development Council, Government of India. Rashtriya Gaurav Award for the year 2015 by the India International Friendship Society, New Delhi, Best Research Paper on Environmental Issues in the Department of Environment. Government of Tamil Nadu State Award for the year 2012. Geotechnical. He was council member of Institution of Public Health Engineers, India for the year 2012 to 2018. Groundwater expert published in Directory of Groundwater Professionals, Central Groundwater Board, Ministry of Water Resources, member in Environmental and Water Resource System Committee, American Society of Civil Engineers from December 2005. Apart from regular academic activities, he acted as PG Environmental Engineering Professor in charge and Environmental Lab in charge, staff in charge of Student Association of Civil Engineering, Department Coordinator for Students' Curricular Activities, and motivated many students to participate in conferences, symposia, and workshops. Acted as chairman in Anna University Central Valuation, member of Affiliation Committee, Anna University, and served as Estate Maintenance Coordinator in Anna University Regional Office, Trichy. Established Environmental Microbiology Lab and part of Hydraulics Lab in Anna University, Trichy. He was a member of Board of Studies and member of Question Paper Scrutiny Board, Anna University of Technology, Trichy. He is Fellow of International Society for Research and Development, Fellow in Institution of Public Health Engineers and Indian Water Works Association, Indian Geotechnical Society, member in the Indian Science Congress Association, National Solid Waste Association of India, Institution of Engineers, Indian Society for Technical Education, Indian Geotechnical Society, Chennai chapter, and Chartered Engineer in Institution of Engineers, India. His research interest in environmental geotechnics and landfill designs, materials in concrete, irrigation water management techniques, water and solid waste management. Thank you, sir.
Thank you, sir, for introduction.
Thank you, sir, for giving the introduction of resource person. Now it's time for technical webinar to start the session. So I request our resource person, Dr. G. Venkatesan, sir, to start this webinar session.
Thank you, ma'am. Just I share the screen for your reference. Screen is visible, ma'am?
Yes, sir. It's visible.
Voice audible?
Yes, sir.
Okay,
Can
thank
start.
you. Thank you for a nice introduction me for Professor Sundaram. First of all, this is a Dr. Venkatesan from Anna University Trichy campus. We are thankful for funding agency for this is a funding agency given to opportunity me carry out the project. So we thank to IRMRA, Indian Rubber Manufacturer Research Association, Mumbai, under leadership of Dr. K. Rajkumar, Director in IRMRA, as well as Dr. Bharat Kappagade, Senior Scientist in IRMRA. And also for given to share the knowledge of this webinar, the management of King's College of Engineering, as well as for Dr. J. Arpuda, GSLV, Principal of this institute, Professor R. Ravadi, HOD of Civil Department, and coordinator of this work, it's a webinar, Professor R. Sundaram, Professor V. Aishwarya, as well as the faculty members of King's College, Dr. Saravana and other faculty members, as well as for other institute faculty members and industrial persons. So first of all, I'm welcome to joining this webinar. Finally, but not least, beloved student community, They are supporting always us to conduct this type of webinar. Today I will discuss with the topic of application of rubberized concrete in construction industry. So of course we have in India for tire or automobile industry there are vast to grow. Now that little bit change the scenario, but anyway that equal of vehicle, especially this pandemic time, most of persons in public transport system is entirely the collapse. So there are some are in individual vehicles, whether the two-wheeler or four-wheeler, what are maybe a lot of automobile related industries boom. Even the somewhere we are aware that some two-wheeler costs as well as four-wheeler cost also there are growing that. But the tire derived the waste material is obtained, if not some extent that there are reusing that tire material, especially for an automobile industry. But it is somewhat in we aware that in rubber industry, especially for an tire industry, they are considered as an hazardous industry. They make it for production lot of tire. They're also that using the consumer maybe due to around 30 or 25,000 kilometers, whether the car or somewhere in a truck, they may we are replacing that because of the safety and other aspects. So we generate a lot of waste material in tire productions or waste things will be there. So of course, in US there are 2 million tons per year. There are produced waste tire material. Some are there are using that in some extents. In olden days, there are put on and landfall. There are dumped with the landfill. It's also causes even incineration is very high pollutant in air pollutions will be creating due to organic content present in the tire. Same like that, the leaching of carbon black and other thing will be. It's also contaminate groundwater pollution in some extent. So it is somewhat a natural rubber. So here present that pie chart. Here for there are India, there are compare summer in China is more produced in natural rubber. In India will be there. So we are of course we are aware that in natural rubber somewhat little bit cost. The rubber board will be there for in Kottayam, as well as the most of natural rubber product we are obtained from in Kerala, some parts of in southern parts of in Tamil Nadu, there Kanyakumari and other places. There are a lot of rubber trees will be there, but they are not meet for an actual demand in consumer or customer. So we need for alternative material. There are some are in synthetic material we are produced for rubber. Most probably they are using that. Natural rubber will be a limited use, as well as if not much too for getting the consumption. So in China is the more product. India will be there in some extent. Same like the recycled material in companies have the for recycled concrete in for, especially we are always a civil engineer are talking about the concrete. Some recycling material that are using up to 12%. Roof shingles is used 11%. So on where the shield, of course the shield will be a good even we are using where we are in a lot of variety now. The in the televisions there are RTS rod for in different companies or different brand. They are only for 60% of steel will be a recycled material. It's also good value. What so I think for your tire rubber 9% is there. We are more focusing on another couple of minutes for only for tire rubber. It's 9%. It is a summer statistics data we are aware that for in globally have 15 million tons waste tire generated annually. India it's also contribute 1 million tires annually. Currently, this waste are buying outdoors for rubber goods. Some are using pyrolysis and road constructions. So we see here for dump or rainfall or somewhat in a huge smoke will be there. It causes underline air pollution. It's don't think that. So we are creating the air pollution in particular source point. It's not the same. The air pollution travel in have few hundred kilometers. Even that's why that we are a lot of facing in Delhi. So the air pollution is not for say, wherever the automobile and other thing in Delhi. There are point sources or non-point sources. Somewhere in other states, Haryana and Punjab, there are after harvesting, there are burned with some material for in a wooden material, other things. It's also causes that. So you travel a long way. It's not have a particular point. They maybe have a travel is some are very tough task to estimate or assuming that for that where the pollutant air pollutant transfer its transfer is yeah, where the bloom will be in apart as manner due to wind and other direction they travel anywhere else, but somewhat limited for say consideration solid waste. We know that dumping yard will be there, have leach out is down road at the summer and groundwater also some extent contaminated. Same like the liquid waste, say for in wastewater streams for conservation air Kaveri in Tamil Nadu. There are starting from Medu Dam to up to for Trichy. There are a lot of point sources that are pollutant in Bhavani. There are some are industries will be there for dyeing industries, Kumarbalim, Palibalim. Same like that, Karur also is there a lot of industries there are disposed for directly in Kaveri River. It's also pollutant. That is the entire scenario. It's for bar chart for number of inspected certified waste motor vehicle recycled and over than for past 18 years. There are some statistical data up to 2015. So recent percentage of recycling, how much we are recycle here for some statistic data we are happening here for somewhat good for steel will be have 80%, 85% recycled. So other materials also higher. Rubber tires is 88% of recycled. So we are more focusing on the waste tire material. How us to have a good material or some are that reuse or recyclable material where our application concrete, especially for civil engineering experts, we are just to search in literature review of the what will be there for using the rubber material for the consideration non-load bearing structures like power blocks. So we need for power block for railway platform and other. Even of course there are temple or whether the car parking as well as some bus stand also we need they report a small bus stand for the power block hollow blocks somewhere in a. We think that for electric pole retaining structures, insulation structures where the waste tire material maybe have identified and use it. So load bearing structures somewhere in railway sleepers if possible, and as well as the foundation material. So good bearing between earth and that's somewhat in base isolation structure. Whether the earthquake and other natural we need for somewhat for some cushion effect needed for that. So we think that so these experts for applications. So somewhere this is a visible literature. I'm not spend much time here. So commercial is a rubber and concrete. So a lot of literatures we have there are available. So most probably have a rubberized concrete is so white concrete. Somewhere in energy absorption is there. Elasticity is there's a good elongation material for rubber. Some action I use it. And sound and heat insulating properties also have a got. So we are identifying some are stronger and weaker area. Have a stronger area, somewhat identify seismic resistance is strong in insulation, increase in elastic property. So weaker area is of course we aware that is not have a good bond between rubber particle and the concrete material, whether fine aggregate or coarse aggregate is not have a good bond. Same like that burning of tire metal is not reused. If not we are a lot of fly ash and other thing we are coal reuse, but if tire bend material is not good for that reusing that for concrete and other aspects for binding character is not much more. So some other other insulating material underpowering that rubber material have some are usually here. So we conclude that if the most focused on in research, we don't think that always the positive research. So we add the some material in the concrete or whether fine or coarse agree replacing that we got it good strength. Only we are accept is not a correct way. Even the negative research also good. So we why not we think that for rubber we are already aware that waste tire material add with concrete definitely reduce the compressive strength. This is a institutionally truth. But we also some extent how to reuse or how to the maximum possible using the rubber material and concrete. That's why we think that even the result will be our less or the values will be less. So what maximum optimum content of replacing of rubber material, how to serve an environment, these aspects we think that, and based on that we have work on this particular project. So this is a focus on main objective. This is research focus on application of experimental investigation on structural and by-toting tire derived aggregate to find alternate waste material wherever possible in construction in industry. The powder as well as fine aggregate are using. Some are in waste in a tire material. There are fiber will be there. That's also that some extent we are reusing. Whether possible to in electric poles to engage to commercial product to reduce utilize waste generated from sources. So this is a methodology of projects. So are literature collections, identification, material mix design, casting. So just to compare with the normal and control concrete to how that replacing that. So finally, I have a result and discussion of this one. So this is a common material used for in concrete. Cement we are using for bar this cement of 53 grade. Reverse sand, it's also used for 4.75 mm. So nowadays we are more talk about for M sand and other type of sand because of the government of Tamil Nadu have banned with wherever the Kaveri Delta region, especially the river coast, they are always taking the river sand. That depth of river will be increasing if not have reach water in Thailand. Thailand also in nature they in meandering and other activity the in for river course they have somewhat little bit produces sand, but we are always leaching under the over mining of the sand if not able to possible for an irrigation and other related activities. So that's why the government is banned. Now we are thinking of an alternative stands of manufacturing sand and other some are using fly ash bricks and other related compound alternative. They somewhat in gypsum that are using for plastering and other work. So we always not depend on one material, we depend on other materials somewhat good for that. So coarse aggregate we taken from various sizes 10, 12, 20 mm. So it's also obtained from somewhat for that one paver block for an AM bricks. There are we are getting from different material, marble powder and other thing. Crumb rubber are various sizes 30 mesh, 40 mesh, and 80 meshes. The various sizes, the crumb rubber is also we are taken from that. So we are taking from two sources. One is from Balaji Rubber at Salem, Arihant Oil and Chemicals at Delhi. We are procure that sizes of rubber. The 30 mesh is almost 0.6 mm. So some are quality also mentioned it here. Waste tire chips is 10 mm. So fiber also we are obtained for in various replacing of concrete. So it's a substance of rubber. It's raw material, common manufacturing, and other details. So somebody please unmute mic, please. 40 mesh and crumb rubber, 30 mesh. So some very sizes here mentioned it. Say somewhere we are using the crumb rubber in simultaneous material in some extents. So we need for some chemical properties of rubber. So our acetone content and ash content well presented here table. Same like that 40 mesh and 30 mesh. So admixtures. So we, of course we are aware that the wherever waste fire matter is not for good bond. So we are some record for chemical treatment. We are with the KH solution with wherever particle the crumb rubber will be we are in immersed with the KH solution. After 1 day we are taking that. So they're dried and using for the concrete and other purposes. So some are air entering agents also we are using for somewhat improve the strength on the concrete. So it is for characteristics of So that's some brand name we are using. Sulfonated melamine based super plasticizer is using that. Water we are using for wherever the local water, our potable water using here. Material testings is a basic test. They are carried out. Sieve analysis, specific gravity, water absorption, and other compressive, split tensile, and flexural tests carried out for concrete specimen. It is a specific gravity of core material here. So rubber. So compare with the whatever concrete material, the rubber specific gravity is somewhat less one. If of course we know for water is one, the below one for crumb rubber and other waste tire shapes 0.962 vary up to zero point 0.1 height. We are some of morphological characteristics we are required for test conduct from XRD as well as SIM and FTIR and other tests also we are carried out. Sieve analysis, this is a simple, we are aware that we are fine aggregate. So mixed design, we are arrived from IS 456 2000 based on the mixed design data M30. We are arrived from that mixed design based on we are taken from water cement ratio trial mix. So M30 is 0.45. We are taken from water cement ratio as well as for water content per meter cube of concrete from table IS 10262 2009. We taken from maximum size of aggregate 20 mm. So M30 design mix is aware that we know that for various type of design mixes. So finally we arrive from that quantity M30 grade for this is a quantity cement, sand and coarse aggregate and water cement ratio. So we are planned to conduct in three manner. One is for cement mortar cubes, as one cement concrete cubes, and finally we are make it for paver black and also that we are tested. So according that we are planned that. So cement mortar cubes we are conduct for wherever the basic strength and other parameters. So working level it is a rubber mortar. The types of mortar is control concrete, percentage of rubber powder replaced, number of specimens and other details. So percent here. Non-treated whether 15% will be add. Pressure rubber 2 to 10%. Air and rubber, it's called as air and agent. We are tied with that. So it is various types will be involved. So other test is we carried out a slump test for an control mix. So some are basic test we are carried out for an concrete and add with the tire material. So it is percentage of tire derived aggregates 115 mm. So where we observe that increasing the percentage of tire derived material, the slump value is decreasing. So we need some air entering agent to add that, or otherwise why we are studying that the bond between that rubber particle and as well as in coarse and fine aggregate, it's somewhat little bit a minimum will be there if not getting the good slump value. So workability. So based on design, we need for a heavily reinforced concrete sections, beam slabs and the slip form work. Pumper concrete is medium. So most student community we are not aware that slip form work. Slip form work is nothing but we have a construct of chimney or silos, especially for a cement plant. So the diameter is high or width is high, 10 meter or 15 meter. A cylindrical portion will be there in cement plant is called as a silo, whether the blending silo is there or cement silo is there. So we are wondering that at the time of I have graduated in 1993 or 95, the siliform technology in India, they are introduced only a few companies like in Satyawal, L&D as well as Simplex as well as Buildmet India. So few companies will be there. But now there are a lot of companies will be there. I also working in Satyawal and as well as Span Construction company for around 3 years for 93 and that period for 95. So it is a very wondering of civil engineering aspects. Say for in a shutter have a 1.2 meter height, the we are most probably have a cylindrical surface will be there. Of course we know that chimney we are seeing that say for a cylindrical hollow cylindrical surface will be there. So inside we have put on shutter, outside we have put on shutter. Just 1.2 height will be there. They all shutters would connected with hydraulic jack. They are lifting that 1.2 meter height. We are up to 100 meter, 200 meter. The shutter will be lifted. We are casting the concrete. That much of technology is available at the days around. I tell that for 25, 30 years back, but now the taper chimney will be there for somewhere we are seeing here for in a thermal power plant or even thermal power protection. There are changing the diameter also. So it's a need for the slump valley. So most probably the pumped concrete they are using for such type of work, especially for in silos or chimney or high elevated apartments. We need for pump concrete. There are slump always to maintain 100 and above 100. That good for the easy flow of the concrete. It is for casting of concrete cubes. So here we are, of course, we are aware that just you mark it, which will not be there and other thing. So we are cost and other things. Just we are think about that. Say flexibility also. We think warm protection. So we need for some theory part here for mentioning that. So how the bond between the rubber and cement matrix interface. So we are rubber and cement. Say the bond will be the fracture sample. Somewhat in cement matrix swat here for footprint from rubber extraction. Rubber and cement model. Somewhat crystalline phase is also identified here for XRD pattern. So mortar test we are conducting the mortar test in our laboratory. Of course, you have size, small size. We not have any put for in only for chips. You have a minimum size of jelly. Have using that. So where the rubberized cement specimen will be there, just you see that the dotted. This is for say just I mark it for mouse. This is for rubber particles. Also is there. It's also for figure A and B dry mass verification, and after that air and we are showing here how will be display code that after that test will be over. So finally we conclude that we are mechanical properties of percentage of rubber compressive strength in a mortar cube for 28 days. The control what will be observed non-treated rubber. So it is also CR will be there for presenting for where is proportionate. AEA means air and aggregate material. So we add with the chemicals, the different mixes, different ratios of compressive strength we are identified. So just we compare that. So here crusher rubber, CR means crusher rubber, AER means air and end. So comparison of 3 days. Say I explain anyone parameter is for 10% of crusher rubber. So here for comparisons of 3 days. We got it for strength of up to 30 Newton per mm squared. For 7 days they have got it 40, and as well as for almost 28 days for in 10% of crusher rubber. So among this we are find that what will be shape are obtained from that after 28 days. So microstructure analysis are also carried out in same pattern. So of course we are aware that this is useful for that. How will the bond between the concrete and the rubber particle? How will be that collider nature will be there and for that. So if this is a simple pattern for XRD X-ray diffraction pattern. Based on that, this is for 2 theta is for wavelength. So say for example, I simply tell that for SI auto. Say for we are think about SI auto, silica part will be there, and for XRD, a silica part to 28 2 theta degree maybe have somewhere here 30 or somewhere in 42 like that will be there. So any chemical component is easily identified using the XRD. It's for rough estimation. Is for only they give the percentage of the chemical component percent in that. So same like that non-treated rubber, we are control concrete. What will be 3% add of non-treated rubber in portions? Some analysis also we are carried out. Same like that 6%, 9% non-treated rubber. So 12%. So is a diagram there are spreading that 15% non-treated rubber. So it is a SEM analysis. So it is treated. So what we are saying, that treated rubber means wherever the raw rubber just crusher powder for, say for example 30 mesh, that they're a little bit washed with the water and dried. Oven dried is not required, it's normal dry. After take it to mix with the concrete and we are make it for test is a non-treated rubber. Treated rubber means we are immersed with the KH solutions and they take from that rubber and make it for a study is called as a treated rubber. So FTIR analysis is carried out in different ratios also here. So 6%, 9% of treated and non-treated. So is peak based on the peak. We have identified that chemical composition of rubber will be varied. So it is another non-treated rubber also seeing here, treated crumb rubber, air and so it is where is graph shows that. So what will be that actual things will be there before casting the concrete and as well as the after casting the concrete, how will be the where the chemical composition present in the concrete. So it is a wavelength for FTR. So we are compressed to all graph for the control concrete here. So 33% non-treated, 6% non-treated rubber, 9% like that. So C2S means is a silica component. So wherever you find that here for that is there, somewhere here is there. So there are symbol where the dollar symbol is the L SiO2. So wherever present, we are just indicating that for make it for adding the rubber, the what component will be increasing scenario or what component is a decreasing scenario we are observed using this graph. Is a testing of specimen. Control specimen versus rubber specimen, we are just to compare with the SEM analysis and various parts. So how the constructor application where will be used for in mortar and cubes and other thing. So it is for crusher rubber and air-ended rubber with also the potassium hydroxide. We are getting that compressive strength. How will be that variant show in the graph here. It's also control specimen. Non-treated rubber also present here. What will be there? So AR specimen results also there. How will be that increasing the rubber content? Definitely we have observed that the compressive strength will be a decreasing scenario. Next one for we are in for hardened concrete test. We are carried out for M30 design. It is a chart maintained for various mixes from the percentage of replacement rubber. We are only for carried out 3 tests: compressive strength, plate tensile strength, and flexural strength with non-treated as well as treated. So the compressive strength we obtained from maximum. There are 6% of non-treated rubber. They are got it for 34 to 2. Thereafter is reducing scenario. There this green color indicates optimum replacement of 6% of non-treated rubber as well as for 9% of treated rubber. So we observe that this is a scenario for maximum possibility to add for rubber without treatment as a 6%. But the unit weight is also very we are aware that if 6% means don't think that the weight will be less. The weight of rubber will be less. The unit weight of rubber will be less compared with the coarse and as well as fine aggregate. Somewhere we are observed to other graphs for optimum strength of cube in optimum usage of tire derived aggregates. So here for 6% of non-treated, same like that for 9% of treated. So in various days 7, 14 and 28 days we have taken optimum as 28 days to mention here. There is a compressive strength of test specimens. Mortar cubes also we are discussing last slides. So will be the mortar cube will be there. So again the mortar cube ratio is 1:3. The out they getting that strength were observed for 9% non-treated rubber adding with the mortar cube. They are getting here for 12% treated rubber. They are getting maximum strength for mortar cubes. compressive strength. So it is the optimum level for maintaining here. It is also motor cube test results. We observed that 9% of non-treated and 12% of treated rubber will be good for motor cube. Compared with in concrete cubes is just 3% add, 6% have non-treated rubber, 9% treated rubber getting the optimum strength. So next one for split tensile strength. Of course, we are aware that some basic and important properties of test on concrete. It is of course we are aware that concrete is weak in tension. So we now they saw the advertisement lot of cement manufacturer. They tell that including some specialized cement will be away up to reach for tensile strength of the concrete in some extent. But the studies also research also is going on, but not up to hit for if not without steel they are using for concrete will be the good or not. The focus on research is still going on. It is necessary to determine tensile strength for load of member where a crack. It is a split tensile strength carried out for in our laboratory. So based on this ratio, we are obtained from that split tensile strength. 9% of a non-treated rubber will be good for the getting that optimum value, as well as 12% of treated rubber they are getting the good values. As per result, rubber concrete improve the creak control. So we aware that for rubber material somewhat an elastic in nature, it's also good for that. It is a split tensile strength of cylinder. It is optimum split value as well as for year 9 and 12%. So next one for finding the flexural strength of the concrete in some action. Prism. So we carried out the test for the prism. So I will be that market for a small beam that called a prism just to mark it and put on apply load. The getting the values of the prism is for flexural strength of 15% of non-treated rubber. They got it good result. So here also for treated also 15% of replacement. So there are slightly increasing. We identify that the compressive strength is somewhat reduced, but split tensile strength and flexural strength of concrete mortar compared to control concrete somewhat good are getting the good results. That's why we need some further research to how to improve the compressive strength, how to encast the rubberized concrete in various aspects and using from in real world problems as well, especially for in civil engineering applications. It is a flexural strength prism. Results shown here. So of course we aware that that's why I am again telling that bending strength of compared with the normal convention cutter is somewhat higher. We are obtained that. So find that corrosion in the concrete for RCPT test which also we are carried out. Rabbit chloride penetration test in some action. So it is a simple concept of RCPT test. So as per ASTM, the whether charge passed based on that chloride and permeability were less than 100, there are negligible, there are greater than 4,000 as a high. So it is a testing apparatus were carried in some other institute, RCPT test. So we are think that why we are paver black we already did it for concrete cube and as well as for concrete mortar. So in real applications, one of our student in ME structural engineering, Vijayarajan Raghavan, is an engineer working in government of Tamil Nadu. We are need support too for an electric pole. So we are give that project and Mr. Vijay Raghavan is execute the project wherever using the electric pole. So electric pole we know that they using the Thane cyclone and other cyclone in Tamil Nadu every year, especially for in southwest monsoon. They started with the month of May end. The June first week in coastal of Kerala and Goa and Maharashtra, the hit entire places as well as some parts of in Tamil Nadu. they are getting huge rain, and as well as now the northeast monsoon started from the month of in September, October, November, and December. Every year there are cyclones will be there, hit a lot of electric poles, especially for Thane and other cyclones for here now located in our institute in Trichy. In Trichy too, where that coastal area for Pumbugara, Nagapattinam, in as well as for in Misal at Pudukkottai district in Tamil Nadu, the air distance almost have a our institute at that place is 150 kilometers or 160 kilometers. But the so where our cyclone hit in our places, including our gym of sports complex, there are destroyed that. So that much of wind blowing is there. So why not we try about electric pole, especially for electric pole in village side, there are heavy damage or causes the electric pole will be broken. So we think that so the electric pole will be the elastic in nature in some extent will be there or not. So we are a real electric pole will be casted here, and there are we are just testing for that pull out test and other thing, but not shown here for mm, shown for here for wherever they're discussing in nature, not shown in results. Only we are just to show that figures only. So based on this, we are conclude that for rubber material, partial replacement of concrete mix using crumb rubber performs suitable for a variety of testers with the acceptance to compare the relationship between the rate strength and increasing rubber content. Rubber concrete is less weight compared to the conventional concrete. It is useful for low weight concrete structural element, especially for we are designing a partition wall or somewhat in waterproofing structures in auditorium as well as for cinema malls. Why not we try that for sheet type of material in feature scope as well as for it's also weight will be less. So of course we aware the dead weight of concrete, especially for in multi-story buildings like that prefabricated buildings and other prefabricated panels. We are using some extents of waste tire material. The KOH has a flexural strength where improve the use of tire rubber particle as addition instead of fine aggregate. So we need for some treatment and how to utilize that waste tire material in some other aspects. The overall results in work shows that KOH treated the tire rubber particles in addition to fine aggregate material may be able to obtain material suitable for building infrastructure and structural material. So the lot of research is also going on. So somewhere in concrete side, the waste rubberized particle they are used for in paver blocks, or if a structural member hit to be there are result will be going on, say especially for in railway sleepers. We think that for railway sleeper, even railway track, the entire load is carried only in railway sleepers. So if designed properly, that would be good. If lead some other issues or bonding and other thing, we will be aware due to for long duration or long time. We are aware that some other rubber particles are especially waste tire. There are used in different aspects for other like toys. Some are we seeing that in wherever two-wheeler footrest will be there. It's also that they may manufacturing only for tire powders, waste tire powders. It's not a new material. It's a footrest as well as for mats, some rubber mats and other thing. There are already there are using for waste tire material, but in a huge or large quantity of waste tire material may be used good for an environment. So wherever safe disposal of an solid waste, especially for rubber material, will be a good for in some extent. They may be, if not have any disposable option for a waste management hierarchy, there are minimum options only for disposal. Other thing recycling and as well as reusable and regenerations is also considered as a huge phenomena compared with the landfills and disposing. So we think about that for rubber material. So how long they extend the using from the concrete. Some few studies also going on for soil stabilization and ground improvement technique for in rubber pads or rubber particles. We are also some research also going on. Of course, fees of air entered concrete into rubberized mortar permitted to occur the satisfactory functionally in spite of more prominent substance of crusher rubber considered in examination. It consists of crisp mortar expanded as measured that AR expanded group. The functionally was observed as was particularly shear content. A potential model partially variable AR and aggregate was proposed. The utilization of crusher rubber total dove into increase or decrease the moisture mass thickness as well as expansion of ingestion and as well as contracted with those quantity got reference to mortar of this thing. The compressive quality of crusher rubber somewhat 1 to 10 NPA and also their increasing scenario as well as for constructive application are proposed based on physical and mechanical properties occurred to investigations we require for further studies for will be that actual study we are in the lab scale study we are carried out somewhere we put on pull out test in electric pole in electric yard we also carried out the strength was a little bit there are increasing that but how long that consistency after 3 years or 5 years there what will be happen will be that so now the same scenario nowadays for M sand and other material replacing we did it for compressive strength and other parameters were executed but they got it good results but what will be durability after 10 years or 15 years what will be there we don't know only for some simulation model and other available softwares available but real world problem how will be there identified that is also very tough task nowadays so potential applications development material where thermal acoustic and austral of vibration properties require were featured in spite of fact air and then rubberized mortar is conjoined non-actual applications it presents both natural and monetary benefits. Of course, waste scrum rubber replacement, all mixes treated and non-treated rubber unit decrease invariable and increase in rubber content. So we are aware that especially for developing in India, developing country like India, so we are minimizing that waste. If and as well as recycling material of rubber, it will be good. I am not talking about rubber, even the solid waste management especially some of most of material imported from foreign countries we are recycling and reusing some other purposes like in south Arcot districts we are in Kadalur a lot of recycling industries will be there they just imported material and recycle and some other using that but minimizing the dumping of waste or wherever the dump disposal of waste will be minimizing that so maximum possibility reuse the wherever the green material will be produced or regenerate the material or same like that retrading will be there for in waste wherever tire so we make it for retrade and using for 2 or 3 times and finally we are disposing that will be good for that some extent again the dumping out created the leach shed and contaminated groundwater pollution in this perspective reuse of waste have particularly huge scope of in construction industry thank okay ma'am thank you for given to opportunity King's College of Engineering Management as well as principal HOD and faculty members and audience as well as participants for uh, giving to opportunity thank you one and all
Thank you, sir. Thank you for the technical session. I hope this session was very much useful to students and faculty members. Now it's time to deliver the vote of thanks. On behalf of our organizing team, it's my privilege to propose a vote of thanks on this occasion. I express my gratitude to the resource person, Dr. G. Venkatesan sir, for spending his precious time to grace this occasion and sharing the valuable concept on application of rubberized concrete in construction industries. I extend my humble thanks to all faculties, students to conduct this webinar session successful. And also I request all the participants to fill up the feedback form to get the e-certificate through your mail. Thank you once again. Thank you, sir.